Now let's see problem B. For problem B, we are asked, we are like to understand the problem quickly. Consider there is an array A. 3, 4, 1, 9, and 8. Okay. Given another array B. What's array B? Array B definition. First thing, it has the same length. And by the way, this function f that they're saying is just take an array and give us the number of distinct elements there. Okay. So let's see, for example, what will be b of I at this place? What will it be? Or let's say at this place, better. At this place, b will be function of f at this place. Wait, I'll change it. Let this one be wait, let this instead of 9, let it be 3. Okay. So the question is, b will be function of f here plus function of f here plus function of f here plus function of f here on. So at this place, what's function of f from here for this segment? 3, 4, 1, 3. So it is 3 plus what? Plus this 4, 1, 3 is also 3. 1, 3, it's 2. 3 only, it's 1. Number of distinct elements. So 6, 8, 9. So the answer here is 9. And so on for all of the array. Let's say for this one, what will it be? Wait, let me clear. Yeah. If we want to see the answer for B here, it would be f function here, f function plus f function here, plus f function here, which will be 3 plus 2 plus 1, which is 6. And so, okay. So what's the question? By the way, same thing will happen for all of them. So what's the question saying? The question is saying, given array B, find any valid array A. What does this mean? Find any array of A that if we try to find its array B, it will be the given array. That's basically the question. If you don't understand what I said, you can just read the video. It's just something, or you can also read the question. So that's it. Now let's try to think about this question. Did anyone notice anything for array B? Let's pick any array B. By the way, it's guaranteed that there's exists at least one. Why they said that? I guess they said that because it's too hard to handle invalid, or not too hard, but just to make the problem easier. There exists one, so we will not be handling invalid cases. Anyway, so let's see this array. Look, for this type of questions, it's good to try to solve it yourself, literally, like by your hand, and try to note any pattern you see, or make another array yourself and try to find a solution for it, and so on. Anyway, so let's see this 1, 3, 6. So what's an array that its A, its B is this? Let's find any array A that do that. First thing, we can put any element here. And by the way, look at this. Any number we should put should be inclusively between 1 and n. Anyway, so let's say the first element is 1. Second element. Is it okay if we said second element is 1? Let's see. If we said 1 and 1, then if its B is what? Its B is if f function here plus f function here. F function here is 1, f function here is 1, so the answer is 2. Is it 2? No. So they should be distinct to achieve this 3. So second element must be not equal to 1, let's say 2. Why I'm just increasing by 1 step? Because I don't want to exceed this limit. Anyway, so next one, it's 6. Can I let it be equal to any of them? Let's see. What will happen if I said 1, 2, 2? If I said 1 to 2, function of f here plus function of f here plus function of f here, which will be 2 plus 1, which is 4, right? And we want 6, so this is invalid. Let's try 1, 2, 1. Function of f here plus function of f here plus function of f here. So it will be 2 plus 2 plus 1. It will be equal to 5, right? So last time we had 4, but now we have 5. It's better, right? So did you notice anything? As we go and choose any of the previous answers, we are getting higher value for B of I. Know that. That's why we try to solve it by hand, to see some observations like that. When we went it 2, it was only 4. When we went it 1, it was 5. So yes, this is an observation, by the way. When we choose one of our previous answers, we are making this one bigger, the B of I. Anyway, so as we saw, even the biggest thing will not let us be able to get 6. So it's a must to choose a new number, which is, let's say, 3. So the answer for this case is just 1, 2, 3. Let's see their answer. 1, 3, 2. It literally doesn't make it, like, it's okay. 1, 2, 3, 1, 3, 2. Everything is okay. Because the values themselves doesn't matter. The thing is make them distinct. Okay. So look, from the observation we just saw, we can literally make an answer. Why? Like we said that whenever we choose one of our previous answers, we are making it higher by 1, higher by 1. So consider the last one. If the last one we choose didn't even give us the B of I we require at this I, then we should make a new value. Okay. So there are two cases. We pick any of our previous answer, and it's still smaller than the required thing, or we add another distinct element that we didn't include before. Two cases. Let's think about the previous case. For the previous case, what's the value if we choose for example, we have here in our previous example 1, 3, 6, and here we have 1, 2, 3. When we said it's 2, just 2, what happens? The function of f for it will be like that, right? It is literally the same as this. The only thing we increased is just 1, because as you see, this f is similar to this f. This f is similar to this f. The only thing is this f. It doesn't exist there. So we just added 1. So if we want a b of I to be b of I minus 1 plus 1, like for example, instead of 1, 3, 6, we want a 1, 3, 4, for example. So in this case, we just have to let this number be the same as this. It is just the same answer, but plus 1. Okay. And that's why when we choose 1, 2, 2, we got 4. Okay. And whenever we go to the left, we are increasing this answer by 1. As we saw when we calculated 1, 2, 1, it was 5. Yes, because we're increasing 1. So we can have a look at the code. The code for this problem, yeah, you don't have to look about the get should function. It's just a checker function that I made so I can check if my answer is valid or not. Anyway, so first thing, I loop through the array for I in range n. I just didn't include the first one because it was always 1. And I made a current, which is 2, so I can make a distinct element as I go. I made a d variable, which is difference. So like, by the way, I call it a, but by a here, I means the array b, which we are already given here. Okay. So I'm asking if a of I equal a of I minus 1 plus I plus 1. What does this mean? If we put a distinct element, what will happen? Note that the previous answer, let's say in this element, it has this f, it has this f, it has this f, right? It has this f. All of these ones will also be for this one, but the answer will increase by 1 here, will increase by 1 here, will increase by 1 here, will increase by 1 here. So if these ones, their count, now I'm I here. So the number of elements before me is just I. And don't forget that I'm adding another f for me. So if I'm adding a distinct element, so then b of I must be equal to b of I minus 1 plus I plus 1, which is the number of elements before me plus me. So then I add the distinct one, and I increase this counter by 1. And if not, like this difference is not that big, then I'm just picking from my previous answer. So len of answer minus d, like the one before me by 1, before me by 2, before me by 3, and so on. And that's the answer.